Electric field due to an electric dipole on its equatorial plane.
So our topic is electric field due to an electric dipole on its equatorial plane. Before we start finding the electric field, let's first find what is equatorial plane. So if you take a charge plus q and place it here, another charge negative minus q and place it at a distance separated by 2a. Such a system is known as electric dipole. An electric dipole consists of two equal and opposite charges separated by some length. Sir, why you have taken this as 2a? So that when I find the distance from its midpoint, the half of the distance will be a. To avoid making it as a by 2, I made it 2a. So let's first define our equatorial plane. So if you draw a line starting from a point, straight line, which is cutting this electric dipole into two equal halves and passing perpendicular, such a line is known as our equatorial plane. And we can find electric field due to this equatorial plane at any point P. So let's first find electric field due to the positive charge at point P. So electric field at point P due to the positive charge will be along the line joining the two, and it will be denoted as our EQ. The electric field due to the negative charge at point P will be also along the line joining the two, the point and the charge, and it will be pointing along the direction towards minus q. So we can redraw this line here. It will be along this side minus E minus Q. Let me repeat again. We have a positive charge plus Q. We have a negative charge minus Q. And electric field due to positive charge is EQ and negative charge is E minus Q. Let's write the magnitude of both of them. So electric field due to the positive charge will be equals to 1 by 4 pi epsilon naught the charge upon the separation. Let's call it as A, let's call it as B. So separation between the first charge and point P is AP and its square. We know this is the expression for electric field due to a single charge. Let's figure out our electric field due to the negative charge. It will be E minus Q, and that will be 1 by 4 pi epsilon naught Q upon BP square. Let me be very careful here. We are not placing the negative sign. Why? Because that negative sign is already included over here in the direction. If this sign would be positive, the arrow would be away from this point P. So negative sign is already included in the direction, and because of that, we will now use vectors to find the net resultant of both these two vectors. Now, if two vectors are like this, we know that their resultant will be pointing from this point along this direction, and this will be our E net electric field. Let's say now this is angle theta here. If this is angle theta, then this also will be theta. Why? Let's now figure it out why this angle thetas are equal. Before that, let me write here the value of this side as A, value of this side as A, and let's say the point P is at a distance of R from the center. Then this will be root under R square plus A square, and this side will be also R square plus A square by using Pythagoras theorem. Let me repeat again. By using Pythagoras theorem, AP will be equals to the square of A square and square of R. So root under R square plus A square. Now since AP and PB, they both are equal, our angle thetas will be equal. In the triangle APB, the angle opposite to equal sides are equal. Now this will be rewritten as 1 by 4 pi epsilon naught Q upon AP square. What is AP? AP is root, so square will remove the root, R square plus A square, and here it will be 1 by 4 pi epsilon naught Q upon R square plus A square, because BP is also that. Now great, after doing this, let's figure out the resultant. So to figure out the resultant, if this is angle theta, this angle will be theta because this will be corresponding angles. And if that is theta, this will also be alternate angle theta. So we can find the components of EQ and E minus Q. The component of EQ along E net will be EQ cos theta. And the component of E minus Q will be E minus Q cos theta. While the component, which component? Perpendicular components, EQ sin theta, which is upward, and EQ minus Q sin theta, which is downward, they will cancel out because their magnitudes are same. So we can write here our total electric field, that will be equals to EQ cos theta plus E minus Q cos theta. And when you take cos theta common, it will be EQ plus E minus Q cos of angle theta. Now EQ and E minus Q, they both are equal magnitude wise, which is we have written here. So when you add both, let me repeat, this expression, orange expression, and this orange expression, they both are equal. So when you add, that will become twice of Q upon 4 pi epsilon naught R square plus A square. Why it became twice? Because EQ and E minus Q, they are same. So when you add them, it will become twice. This will be cos of angle theta. Let's take the triangle PA and let me call it as any point O. So A, P, O in this triangle, what will be our cos theta? Cos theta will be base AO upon hypotenuse AP. Sir, AO is what? A, and AP is what? Root under R square plus A square. Can I take, sir, POB? Yes, you can. You will get the same result. So let's take it on the other side and let's substitute the value of cos theta here. This will be equals to 2Q upon 4 pi epsilon naught R square plus A square, and cos theta is what? A upon root under R square plus A square. Now this root, we can write it as power half. So I'm just removing this root and we will substitute here power half. So let's write here as our power half. Now let's multiply it inside to get our net electric field. So you can see here the net electric field E net will be equals to twice of AQ whole divided by 4 pi epsilon naught R square plus A square. Now this is power 1 and this is power half. So this will become power 3 by 2. Now if you look at the diagram, the direction of electric field is pointing in this direction, while the direction of dipole moment is always from negative to positive charge. Let me repeat again. The direction of E net is on the right hand side from left to right, this side, and direction of dipole moment minus Q to plus Q on this side. Since they are both in the opposite directions, so we can also rewrite this expression as E net equals to, this 2AQ is nothing but our dipole moment, but we will place a negative sign. Why negative sign? Because dipole moment is in the opposite direction to the total electric field. So this is our total electric field at any point on the equatorial plane, where R is the position from the center of the dipole along the equatorial plane, and A is the separation. Twice of A is the separation. So A is half of the total separation between the two dipoles. Let's take a special case. If R is much greater than A, then R square plus A square will be equals to nearly equal to R only, R square. Let's substitute here. So E net will be simply this is a special case. So minus P upon 4 pi epsilon naught R cube. This is our total electric field along the equatorial plane.